In this video, we're going to review the 4 levels of data, as well as measurements of central tendency and dispersion that are associated with each of those levels. The first and lowest level, the level that gives us the least amount of information, is the nominal level. So nominal data, so the data in a nominal level variable, consists of unordered categories. That is, each of the data points is a category, it's a word, and there is no inherent way to sort the data. So as an example, I have the nominal variable color, and our values in that variable are blue, green, and red. So these are colors, they are categories, they're words, and there's no inherent way to sort these. So I have this in alphabetical order, but we could have had green up here, and then red, and then blue, or any other permutation that makes sense. There's not too many ways to rearrange those, but we could rearrange them in any way we wanted, and no order would necessarily be correct. There's no inherent way to order them. That's really what defines the nominal level. We have categories, and we cannot inherently order them. That is also what differentiates nominal from ordinal. So in an ordinal level variable, we still have categories. So in this case, we have words, first, second, and third, but there is an inherent way to order these. First is better than second, which is better than third, or first comes first, followed by second, followed by third. We cannot assign the second and stick it up here. That kind of violates the natural order of things. If we could do that, then it's actually a nominal level variable. So ordinal level data, we still have categories, but there is an inherent ordering. Note that I have the word first, second, third, so we may be tempted to replace this with number 1. And the second we could replace with the number 2, and third we could replace with a number 3. So now it looks like we have numbers instead of categories. That's a nice try, but it doesn't work that way. As long as your interpretation of the data is that 1 is a category and 2 is a category, then we still have ordered categories and our data are ordinal. It doesn't matter if what we're seeing looks like a number if it is still behaving as a category. That is that behavior, that interpretation of the data that defines whether or not we're here in the ordinal or nominal, so we're talking about categories, or if we make the break and the jump into the interval ratio level data where we have real numbers. So these are not categories anymore, these are actual values. For interval data, again, these are actual numbers. We can do real math with them. They may have decimal places in it. They may be negative. They may have a 0. All of those are acceptable and help tell us that, yes, we're dealing with interval and ratio data. Again, these are not categories, so they're not ordinal level. For interval level data, we have numbers, and because we have numbers, we can subtract them. So we can do 6 minus 5 and get 1. We can do 7 minus 6 and get 1. And 13 minus 13 and get 0, and that's all fine. So we can do addition and we can do subtraction. What we cannot do with interval level data is trust division. And technically multiplication, but division is really the big one. Ratios are not constant with interval level data. And that can be kind of a difficult concept, so I have that outlined over here. So here in the interval 1 category, or column, I've just copied over what we have here, the same data set. This is the time. And interval number 2, I've taken this value and I have subtracted the number 4 from it. So 5 minus 4 is 1, 5 minus 4 is still 1, 6 minus 4 is 2, 8 minus 4 is 4, and so we've just done this all the way down. So I've taken my interval level 1 and I've shifted it over to the left by 4 units. Now let's go calculate some simple summary statistics. We can take the minimum of this data set. And since I have it sorted, it's pretty easy to find this out. The minimum is 5. The maximum value is 13. And I can calculate a difference. We can do differences with interval level data. 13 minus 5 is 8. So there we go. I can also, in this particular case, try calculating a ratio. So let's do 5 divided by 13, and that gives a ratio of 0.38. So the math works here. 5 divided by 13 really is 0.384, etc., etc. Now let's do the same thing with our interval 2 data. So remember, our interval 2 is this column, and I've subtracted 4 from each of these. So we have a new data set, but one that's related. So our minimum is 1, 5 minus 4. Our maximum is 9, 13 minus 4, so that's all fine. We take a difference of our maximum minus our minimum, and it's still 8. So we get the same value, and it doesn't matter that we've subtracted 4. Because we've subtracted 4 from the entire data set, the difference from this one compared to this one is still 8. Again, addition and subtraction works just as we would expect for interval level data. But if we now take the ratio of the minimum divided by the maximum, remember min divided by max over here was 0.38, now min divided by max is 0.11. So even though this is kind of the same data, we took the data and we subtracted 4, because we are allowed in interval level data to shift our 0 point, so we can arbitrarily add and subtract numbers from this, our differences between values stay the same, but our ratios between values do not stay the same. And it is our inability to maintain a constant ratio that says we're in the interval level data. So we can do differences, but we cannot do ratios. And again, by cannot do, I don't mean we can't calculate ratios. I mean, if we were to adjust our 0 points, if we were to arbitrarily add or subtract things, then our ratio will change, but our difference won't. For a ratio level variable, our ratios hold. And how does that happen? Well, for a ratio level variable, we have a meaningful 0 point. So we cannot, really what that comes down to is, for a ratio level variable, we are not allowed to do this. We can't arbitrarily subtract 4. And because we cannot arbitrarily subtract or add 4, then we cannot run into this bubble. And so we are stuck, we're not stuck with, but we have a ratio level variable. Our ratios will always be constant because we cannot arbitrarily add and subtract like we can with an interval level variable. So those are the 4 categories and kind of how they work. So how does this relate to our measures of central tendency and dispersion? So central tendency is our representative value. It's kind of our best way of summarizing a data set, and especially in a tabular format. And we learned 3 primary ways of doing that. The first is the mode, and the mode of a variable is the value in the variable that appears the most often. So in our nominal level variable color, we have 3 values, blue, green, and red. And blue appears 6 times, which is more often than green or red. So blue, the word blue, or the category blue, is the mode of this nominal level color variable. For our ordinal level rank variable, and I just came up with these names, for the rank variable, the category, or the word, first appears more often than second or third. So first is the mode. It is the value that appears the most in the data set. For interval level data sets, or for the interval level data variable time, the value 5 appears more than anything else, so the mode equals 5. And for the ratio level variable count, the number 4 appears more than any other value, so that is our mode. So, as you can see from that, the mode is applicable to any of our kinds of variables. We can calculate a mode for nominal, ordinal, interval, and or ratio level data. And I have that highlighted in blue, so those are the modes for each of those. The next central tendency we looked at was the median. So the median is the middle of our data after you've sorted it, and it is the middle defined by count. So that's kind of a weird way of saying it. Really what we do is we take our full data set, we sort it. So we can't take a median of nominal level data. So the key, or a key to calculating the median, is we have to be able to sort our data, and nominal data are unordered. There is no inherent way to sort this data. Since we can't sort it, we cannot take a median of that. Ordinal is ordered, so there is a way to sort this, and interval and ratio are numbers, so we can, of course, sort those also. So we can calculate a median for ordinal, interval, and ratio level data. After we sort our data, we split it into half. So we count the number of data and find where the midpoint is. In this case, I have an odd number of data, so there is a very handy midpoint, and I've highlighted that in yellow. And that is the median, is the value that appears in the middle of the data set. So there's an equal number of data points below the median and an equal count of data points above the median. Now, other than doing the initial sorting, the median doesn't care what the magnitude of these values are. So this could be first, second, 50th. As long as they are properly sorted, it doesn't matter that this is third place or 50th place. The median does not change. That makes the median very robust, or invariant is another way of saying it. It tends not to change due to extreme values because the median only cares about the rank order. It only cares which value needs to go here versus here versus here, and doesn't care how big those values actually are. That is in contrast to the third measure of central tendency, the mean. So a mean requires real numbers. If you remember the mean, the general arithmetic mean is the sum of values divided by the total number of values. Well, we can't add the word first plus second, so we have to have a real number. So we cannot use ordinal data, which are categories, we cannot use nominal data, and we can also not calculate a mean for ordinal data. We can only use the mean on real numbers, the interval and ratio level data. The mean is, well, we can compare it to the median. So the median was the middle of the data by count. So half of the number of data were here, half the number of data were here. The mean is the middle of the data by data value. So the median did not care if this was second place and 50th place. The median doesn't particularly care that that value is 13 versus 50. This would still be the median. The mean does care about that. It is very sensitive to how large these numbers actually are. In Excel, we can, I don't seem to be able to click on anything. In Excel, there we go. We have a handy function for the average. The simple average, again, is just the sum of all of the values divided by the total number of values. We also learned about a weighted average, which we will cover later in a different reminder video. So that's the mean. It is the middle of the data where the values actually count. So kind of a balancing point of the magnitude of the values. The median is the balancing point of the count of the values, and the mode is just the one that appears most often. Those are our measures of central tendency, our representative values. But we do need to ask the question, if that is our representative value, how representative is that value of the data? And that gets into a question of dispersion, so the spread of the data around our measure of central tendency. There's really, even though I presented more of these in class, there's really two of them that we tend to use the most often. And the first is the range, and that is pretty much what we did here. In fact, it is exactly what we did here. Is the maximum value minus the minimum value. So it is the literal spread of the data. The range is a single number. It is the number 8 here. It is not an interval, even though that is the way we calculate it. A range does not apply to nominal data. Here, really, we can only give the number of categories. The range does not really apply to ordinal level data because these are also not numbers. We can't really do third minus first, the word third minus the word first. So this also doesn't really work. We learned about this thing called the index of dispersion that works for these guys instead. But I'll admit I haven't actually seen that used in practice. For interval and ratio data, we can calculate a range, but as we've learned, certainly when it comes to applying the normal curve in the t-distribution, we've learned about this thing called the variance and the standard deviation. And those are, for hypothesis tests in particular, those are our go-to measures of dispersion. And they have handy Excel functions like var.s, and the standard deviation is the square root of the variance. Some things like that you can look up on these slides. There is another measure of dispersion, the median absolute deviation, that I'm personally a huge fan of, but we really didn't talk about it in class and how it gets used. So honestly, don't worry about that for final exam purposes. I think that is all I have to say about that.